Hello everybody. I really miss seeing you all in class. I miss teaching you, and so here's my mini lesson. This is going to be on something that you already know. You learned about laws of signs in geometry class, I believe, but I feel that this is a great review, and this is especially for my future math team members. We'll review this, we'll review laws of sines today, and then we'll review laws of cosines tomorrow. That's all connected to trig, so again, as I said, we'll be reviewing the trig unit this week. All right, so the first thing, we are going to start with a nice triangle. And I'm going to name this as triangle ABC. Opposite side to the angle is going to have a lowercase letter. B is right here, and this is side C. Definition of laws of signs. Well, laws of signs we can apply when we have three things given in a triangle: angle, angle, side, or side, side, angle, or angle, side, angle. All right, those are our three cases. Remember, order matters. So if you have three given informations, you can use laws of signs. All right, the definition of the laws of signs says that if we have sine of angle A divided by A, this is going to be equivalent to sine of angle B divided by B, and this is going to be equivalent to sine of C divided by C. All right, now of course we are not going to use this as three things. We will look at what is the given information, and then we will just use, for example, something like this. A divided by sine of A is equivalent to B divided by sine of B. Well, look at this, I wrote it backwards. Is this still a true statement? Think about the proportions. Yes, it is. You can write it either way. You can put, as long as you don't mix them up. So see how the signs are on the top of the fraction in the numerator. Here they are in the denominator. As long as you are consistent, this is good. B over sine of B is equivalent to C over sine of C. Again, I wrote this backwards, but it's still the same. All right, let's take a look at quick example. I'm using your textbook, so you can go back there and take a look at what is how the textbook explains this. I'll give you a page in a second. But here's example number 1. If I have a given information that C, this is the uppercase C, so that means that this is going to be an angle, is equivalent to 102.3. B is equivalent to 28.7, and B is equivalent to 27.4. I want to solve the triangle, and that means that I want to find all the missing values off of that triangle. All right, well, the first thing, as always, draw a picture so you know what we are talking about. I am going to name this triangle as A, B, and C. Therefore, I know that this is A, this is C, and this is B. And the given information says that this is 102.3. Look at this one, it almost looks like an obtuse angle. B is 28.7. And side B is equivalent to 27.4. All right, well, what is the thing that I can find first? There's this angle A, and I can very easily find it because if I do 180 degrees and I take away 28.7 and I take away 102.3, I am going to get, well, I did this a second ago, and I am going to get 49, I believe. So what I have is that angle A is equivalent to 49 degrees. Okay, so still I do not know what is my side C and what is my side A. So I am going to use the laws of signs, and I will use the angles that are given. So if I use this angle, I will be able to find the side C. So I am going to say sine of C divided by C is going to be equivalent And now look at this one. I'm going to use the b as those two, the side b and the angle b are given. So I'm going to say sine of b divided by b. Sine of c, so c is 102.3 divided by c is equivalent to sine of b divided by 27.4. I will move my paper up. Okay, I want you to pay attention. This is the most important thing, is that we only have one unknown. This is the only thing that we do not know from this equation. Cross multiplication is a good strategy to use. So c times sine of 28.7 is equivalent to 27.4 times sine of 102.3. I am going to divide both sides by sine of 28.7, and once I put all this mess into the graphing calculator, which I do have, and you don't need to use the graphing calculator, you can use any calculator. You know what, I was just teaching my daughter how to solve system of equations using matrices. You have to make sure that you are in degrees. So here we go, that's the first thing. And then I am going to say 27.4 times sine of 102.3. I'm going to calculate that, and I'm going to take the answer and divide it by sine of 28.7. And let's see what happens. It tells me that C is equivalent to 55.74. All right, I will take this as my answer. And notice that I am not done. I still have to find A, and I think the best way is to use the laws of sines again. So here we go. We now know that this is 55.74. And now I'm going to use the laws of sines, and I am going to say, for example, sine of 102.3 divided by 55.74 is equivalent to, now I need to find this one, so I will use angle A, which we already found, sine of 49 divided by A, cross multiplication, is equivalent to 55.74 times sine of 49. And if you do all the work, you will get that A is equivalent to 43.06. And here's our answer. We solved our triangle. What I want you to do now is I want you to pause for a second, and I want you to look at example number 2. It is very similar, and it should be pretty straightforward. Once you are done, I want you to look at the page 496. And on page 496, you have the ambiguous case explained. This case applies when you have side-side angle given, and you can have 3 choices there. Once you solve a triangle like this, you can have one solution, you can have no solution, or you can have 2 solutions. Please analyze example 3, 4, and 5. And analyze the blue definition box on page 496, and that explains what is going to happen and when. What I want to do is I want to talk about the area of the oblique triangle. and then we'll finish there. So there's a formula of a triangle that will include trigonometric functions. Well, again, let's start with drawing a picture of a triangle, and then we'll talk about that. So if this is A, this is B, and this is C. This is my side A, this is my side B, and this is my side C. What I am going to do is I'm going to draw the height. The reason why I'm drawing the height is because I know that the area of a triangle is equivalent to 1/2 base times height. And what I want to do is I want to see what I can replace the height with in terms of trigonometric functions. Well, because we've been talking about the laws of sines, I want to think about this for a second. What is going to happen if I say sine of B? Well, everybody remembers SOHCAHTOA, so sine of B is equivalent to h over A. Okay, very nice. Let's see what the h is equal to from this equation. So if I multiply both sides by A, I will get that h is equivalent to A sine of B. And what I can do with this is I can replace it into my formula. So the area of this particular beautiful pink triangle is going to be equivalent to 1/2. My base is C, and then I'm going to multiply it by h, and this is h. So A times sine of B. Well, I should have made it a capital B, of course. I am going to rewrite this nicer. 1/2, I will put those letters in the alphabetical order. So I have AC sine of B. Let's see what happens if I take the other side of this triangle. Sine of A is equivalent to h over B. Therefore, h can be replaced with B times sine of A. If I do this, this area of the same triangle could be described as area is equal to 1/2. Base is still C, in this case the way I draw the triangle, and then I am going to multiply it by B sine of A. Again, I am going to rewrite this nicer. 1/2 B C sine of A. And now notice that the only formula we don't have written is in terms of angle C, but we know that mathematics consists of beautiful patterns, and of course we could prove it, but could you predict what it would be? Notice every single time we have our 1/2. If I know that I want sine of angle C, take a look at this one. If this was angle B, I used A and C. This was angle A, I used B and C. This is angle C, so I will use A and B. Those are our three formulas that we can use to calculate the area of a triangle if we have an angle given and those sides, angle, those sides, angle, those sides. So you have three different types of formulas, and depending on the problem that you have given, you can use one of those. All right, what I would want you to do is I want you to analyze example 6 and also example 7. And I will write an assignment on I'll post the assignment on Teams. All right, have a great day, guys.